Hello, everyday statistics, and welcome to lesson 2.7. We're going to be assessing a regression model. So we're going to be able to see um, using a residual plot whether or not a certain association is appropriate to model using a least squares regression lines. Let's get right into it. So in this day, we're in this lesson, we're going to be able to, like I said, use a residual plot to determine if a regression model is appropriate. We're also going to be interpreting the standard deviation of residuals and R squared. We've looked at R. We also have an R squared value as well. So when we're looking at a regression model, sometimes we'll have some data that fits a curve and is not linear. We need to determine how we would do that. The way that we would do that is by looking at the residual plot. If we don't see an overall pattern in the residual plot, then we'll know that a least squares regression model is going to be appropriate. Let's look at a residual plot. So here we go. We've got a scatter plot over here with Super Bowl number and the cost of a 30-second commercial. And then that's on the left. And then on the right-hand side, we actually have the residual plot. So what this residual plot is doing is it is looking at these distances right here. So, and this distance here, right? So it's looking at the distance from each point to the predicted line, right? So that least squares regression line. So you can see, right? This point right here, let's look at this endpoint right there, right? It is very far above my least squares regression line, and that is the same point, really far above my least squares regression line. Let's look. I would think that maybe this point right here is very possibly this point right here, right? We look and we see the distance away. It's right next to another point that is a shorter distance, right? We see that this is a fairly good distance away, and it's right next to another point that's a distance below. So all this is measuring the distance above or below the least squares regression line over here, and this, which is our residual plot. So we're going to notice that this residual plot has a pattern as well. You'll see that it follows almost like a quadratic looking pattern, right? That's what we're looking for if we're going to, so that's what we're looking out for, I should say. If there is a pattern like that, then we would say that this is actually not an appropriate, this is not appropriate for least squares regression because of the pattern. And I'm just going to say least squares regression, okay? And that's what it's saying down here. It would not fit very well. You're always going to have some weird prediction. So in other words, right, all of these predictions for all of the predictions for these particular values are always going to be higher than the actual values. So we also wouldn't want to use it for that reason. But the main thing that I like you to look for is look for this curved relationship on the residual plot. So we looked at one that was not appropriate to use a least squares regression model for, but this one will. If you see over here in our residual plot, there is not a pattern, right? If I was to try to, connect to the dots, I wouldn't see anything, looking like that, or, looking like this if I was to connect to the dots. I don't see any clear pattern. In fact, it's very scattered all over the place. And that's awesome. We like that. We would say that this line is a good fit for a least squares regression. And this is essentially just saying the same thing that I've been telling you. They're saying a leftover pattern. I'm saying if there's no pattern, right? If you couldn't look at it and it looks like some nice curve, then you would want to use a least squares regression. All right. So now moving on, let's also interpret the standard deviation of the residuals, right? So what that is it tells you on average how far away each actual observation is away from the predicted value. So on average, how far it is away from the predicted value. And we'll interpret that in context here in a little bit. We'll also look at the coefficient. We're also going to be looking right now at the coefficient of determination. That's r squared. Really, all you gotta do is kind of memorize this script, right? R squared measures the percent of variability in the response variable that is accounted for by the least squares regression line. So all you have to do is input in context what you're doing. So it measures the percent of variability in the response variable, and you're going to insert something in context, right? If it's time or something like that, we'll insert it in there, and I'll show you. We'll use this here in a second. All right. This is a picture of what we're doing when we're looking at r squared, right? We're trying to reduce the residuals, but it can only be done by 60%, 66% in this case. And by the way, don't focus too much on that stuff. We're just going to be interpreting r squared in context, right? And so this is perfectly what I'm looking for when you're being asked to interpret in context. That is, you would say the percentage of variation or variability in and look, this is our response variable, is accounted by the least squares regression line. This is exactly the way that we would want to say it. So this is the sentence that we're looking for. If you're being asked to interpret the r squared value, you're going to be looking for a sentence just like that. You're looking to make one. So let's go ahead and work through an example where we're going to determine whether it is appropriate to use a least squares regression, and we'll also interpret the standard deviation of the residuals and the r squared value. All right. R squared, also known as our coefficient of determination. All right, so here we go. We have our residual plot shown, and we're seeing if we can predict the battery life of a tablet using the price. So does a more expensive tablet have a higher battery life? Kind of what we're looking for. That's what you would use this model for. So is a regression model appropriate? So it does look fairly scattered, but unfortunately what we've got going on is, look at this curved pattern. I don't like that at all. So this particular residual plot is showing a curved pattern. So I would say that it is not appropriate. So for the answer to number 1. I would say there is a curved pattern in the residual plot. Well, not a plot, but a plot. It is not appropriate. Fantastic. Let's now interpret the value s equals 1.21. Also known as the standard deviation of the residual. So let's go ahead and just get this on a different page so that we can just have a little more space to interpret this value. So we're going to interpret the standard deviation of the residuals. So here we go. So when using a least squares regression line to interpret, I should say, to predict and what are we predicting? What does y hat predict? Battery life. Predictions will be off or will vary from actual values or observed values. Very important. Let's see, I'm going to say on average here in a second. That's a very important dimension. By 1.21, what are our units? 1.21 hours. Thank you. Hours. Hours on average. Okay, if you do not say this, it is not right. Okay, because it's just an average. This is on average how far off they are. It's not how far off they're going to be. Just an average of the distance from of each predicted value's distance from the actual value. Well, that's how you would write that. Okay. So when using a least square regression line to predict battery life, predictions will vary from actual values by 1.2 hours on average. Gotta say on average. Now let's look at number 3. Let's interpret the value of r squared in this context. So first thing we're going to need to do is we're going to need to write this as so you can write this also as a percentage. And I think that is it's more helpful when we're writing this interpretation. So what we'd say, if we could say 34.2%, or we just write the percent, so be easy with that, percent of the variation in our response variable, which is battery life, variation in battery life. Remember, this has to be our response variable. Can be attributed or accounted for by the least squares regression line. And that is that. That is how you're going to interpret it. Just remember, you've got to have this here, right here. You can make the exact same sentence, right? And you're just going to input your explanatory variable here, or your y hat. Right, in context. And that's all you got to do to write that sentence, okay? Just change that one word. And then, of course, you know, this is going to be whatever r squared value you've been given. All right, well, today we have done all of these things. It was awesome. Thank you so much for watching. I hope you're having a fantastic day. And if you're not, I really hope it gets better. Thank you. Remember to take care of yourself.